All right. So I have to ask Benjamin, how many cookies do you have by now? So Benjamin's playing Cookie Clicker and has 221 quindecillion. I have no idea what that is. That is a very, very big number. All right. So welcome everybody. Let's see. So today we're going to be covering programming. And this is actually one of my favorite classes because I think that anybody can learn to program. There's all kinds of different programming, and some programming is really complicated, but what I'm going to teach you is really more like scripting, and scripting kind of leaves a lot of the complex and more fiddly stuff involved with optimization, for somebody else to take care of, and we get to focus just on gameplay. And so I think that it's really great if, for anybody to learn. Oh, hey, Jesse's here too. I'm going to go let him. I'll be right back. No worries. Take some deep breaths. So Jesse's joining us here. I know Martin sent me a message and can't make it to the class tonight. So make sure that all this is recorded so that he can see it. And as I was saying, tonight is the programming class, which I'm a huge fan of because I think anybody can learn to program. Does anybody in the class have experience programming? Yeah, you've done Python, Jesse? Uh-huh. And what about you? Mm-hmm. All right, Python Lab, huh? Yeah, Python is a really useful language to get into, and it's quite accessible, has a lot of uses. And so, one of the things that we'll be doing is talking a bit about the aspects of programming that are going to be the same no matter what language you use. And then we'll get into the specifics of using C# in Unity, which is the scripting language that it uses. But what we want to do first is a little bit of setup. As usual, it's beneficial to go ahead and set up the Unity project while I do like a brief intro, because remember, it takes a little bit of time. So I'll be doing this just the same as you will. So for our programming class tonight, as a preview, we're going to start out really basic and simple with like a debug print statement. We're going to do some simple translating of a 3D object, making it move through a scene. We'll do some scripting, spawning and despawning. So we'll create things and destroy them. But in order to do that, you're going to want a Unity project that is a universal 3D project. And so let's see. So for me, when I click New Project, Universal 3D here is the one that we're looking for. You might be in Core, that's fine as well. Let's see, and you'll see that there's a lot of different types, but we don't need high definition. We just need regular Universal 3D. So give your project a name. You might just call it like, DNA programming class. It looks like I already have that from when I did this previously. Note where you've saved it. It's probably usually the same place you've created prior projects. So it's going to take a little time to build that. Well, that's good though, because this class has a little bit more of a warm-up than most classes. because what I want to do is I want to talk about the basics of programming before we get into actually doing the work ourselves. The classic programmer problem, maybe you don't understand why it works, and then it works, and you don't even understand why it works. But programming is really useful. There's a handful of programming fundamentals that we're going to learn about, like variables, conditions, loops, and functions. And those of you who have some experience with Python or other languages, some of this will be familiar, and you'll be like, oh, I know what that is in Python. Now you just need to learn what it is in C#. We'll create simple movement using scripts. We'll spawn and despawn. We'll use triggers to create interactivity, and we'll do that by importing that third-person controller from the Unity asset store. So we have a character that can walk around in our scene and hit an invisible trigger. So let's start with programming fundamentals. So essentially, the reason why we program is because games, the thing that makes games different than all other media like television or books or art is that it has interactivity, which means you can do something and the game responds to you. And that happens because of code. So what can programming do for you? It can make something happen when the player provides an input. So like if you're pressing keys on the keyboard, moving the mouse, or using a gamepad, those inputs are translated into things in the game thanks to programming that is working with the player controller. You can keep track of score, and when the player wins or loses, we'll actually do this by creating a game master in a later scene. A game manager, is the script that usually kind of pays attention to things like the player died and now I need to respawn the player, or the player scored some stuff so I need to update the UI with their score, or the player made it to the end of the level so I'm going to move on to the next level. Code can control an AI and tell it to move, attack, and react. One of the things I did when I worked on Avatar Frontiers of Pandora is worked really extensively with the NPC AI behaviors. That can get pretty complicated, but actually doing simple versions of that, we already saw when we did the 2D game, and we noted how the enemies could just move back and forth on a simple line. We can connect the user interface to events and information, like if you press the pause button, it pauses the game, or if you press the start button, it starts the game, and a whole lot more, of course. So there's a lot of different programming languages. JavaScript is really common. A lot of people learn HTML early on because it's pretty basic. You mentioned Python. C# is popular. C++ is the programming languages that most game engines use because you can do really low-level stuff and you can optimize to make sure the code runs really fast. PHP, others. But some things are common to all programming languages, and that's variables, conditions, loops, functions, and those are the basics, and that's what we're going to learn first. So first off, what are variables? So a variable is essentially a container that stores information. You can think of a variable as a labeled box. It generally has a name. The label is the name of the variable. So for example, you can see here's a variable called age, and the value of that variable is being set to 25, but the variable is age. You can have a variable with name, and the name could be equal to Alice. And you could print, hello, and then the name, and it's going to replace the variable name with Alice and print hello, Alice. So you can think of the contents of the box are the value of the variable. You got the variable name and then its value. The value has a type. So that can be, you can see here, age is a number. Name is a string, which is a series of characters. So a word in this case. But it can also be other things. You can have variables that hold game objects. You can have variables that hold sprites. Variables that hold 3D objects. So pretty much anything that's an asset that you would find in the project could be a variable. So and code can refer to variables. So that's what makes it useful. So they're used for things, the reason why they're useful is, for example, reusability. You can reuse a variable multiple times through your code, so you don't have to, if you make a change to that, like if you had the variable age in multiple places in your code, then you could change the value of that, the variable age, and it changes it everywhere, instead of having to update every single instance. So flexibility, if the value changes, you only need to update it in one place. And readability, variables give your code meaning if you name them intelligently. So it's really important to, because you can name your variable pretty much anything, it's important to give it a useful name. You might be tempted to give it a goofy name, but if it causes confusion, that's not terribly helpful. So that makes the code more readable. So next up is conditions. Conditions are a statement that lets a program decide whether to do something based on whether the condition is true or false. That's called evaluating the condition. So for example, if age is greater than or equal to 18, you'll do this. Otherwise, you'll do this. So, in this case, since age is 16, it will say, okay, this is false. So therefore, we're going to go to the else statement, right? You are a minor. You're under 18. I don't know if that's the same in Sweden, to be honest. That's very American view. But the point is, these comparisons, so you're comparing the variable age to a value, the value 18, and here you see it's greater than or equal to is used to create the comparison. But there's other comparisons. There's greater than, less than, equal to, not equal to, and also logical operators like and, or, and not, which we'll get into later. So next is conditions are used to allow you to have your program make decisions. So based on the input, if the player is pushing forward, then move the character in this direction. So essentially, you're saying like, okay, based on things that are given to the program can make a decision, go in a different direction based on evaluating that condition. So this creates dynamic and interactive programs. That is at the heart of interactivity. So you can see where these two things can work together. Variables and conditions are usually combined. It also allows you to handle different scenarios with different rules. If the player presses left, do this. If the player presses right, do this. If the player presses the jump button, jump. So next up, loops. Loops are very commonly used. They're a structure that allows you to repeat a block of code multiple times. So in this case, while the count is less than or equal to 5, write the number and then increment count. So it'll print the number, it'll go through the first time and it'll print, starts out at 1, then it increments to 2, then it'll print 2 and it increments to 3. So it keeps looping. So this is useful when you need to perform repetitive tasks. Like for example, you might want to have the program listen every frame to see if the player pressed a button. And so it's constantly waiting and listening for input. And if there's input, it'll do something. So there's loops built into the structure. Like one of them that you'll see is the update loop. Every time you create a new mono behavior, a new script, it'll include start, the thing that it does at the beginning, and update, something it does every frame, which you can use if it makes sense. But that's a very common loop. So there's several types of loop that are useful in different circumstances. So based on how many times you need to loop, and if you know the exact number of iterations in advance, you'll use different things. There's while, there's for, there's do while. There's different types of loops, but they have different purposes and they're useful for different things. So they're used to iterate over data. So like if you had a list of things and you want to check everything in that list, you might want to loop over all the items in that list to see like, okay, are any of these enemies still alive? If so, then the player hasn't defeated the wave yet and the game is still going to go. So if you want to repeat actions until a condition is met, sometimes you have that the thing that is checking at the beginning of a loop, sometimes you have that thing that is checking at the end. So those are two different ways of approaching a loop. So you might be waiting for the user to give input. You might be running a calculation until the desired result is achieved. And it helps you write cleaner and more concise code by reducing repetitions. You could check every single thing. You could do a line of like, if this, if this, if this, if this, if this, if this, if this. But instead, you could just write a tiny bit of code that says, until this, keep running and loop. And so that allows you to write a lot shorter and cleaner and easier code. And then there's functions. So essentially, a function is a block of code that performs a specific task and can be reused. Like if I had a function called check my email, anytime I wanted to check my email, I could run the function check my email, and it would do that, and it would return if there's email that I should check. So if you're gonna do something frequently, it's easier, rather than writing all the code over again every time you want to do something, you can create a function. And a function is like a task that you know that you're going to do frequently. Then you call the function anytime you want to do that task. So you can separate tasks into smaller manageable parts, and it's actually a lot easier to think, okay, what I need this script to do is first, I need it to like check the player's health. And then I might have a function that's like, determine if I should end the game based on the player's health. And those could be two separate functions. So this helps make code more organized, readable, and modular, and reusable. So like you could actually write functions in one game that you might reuse in another game. And that's pretty common. So key parts of a function. So you have the declaration, like that's the function's name. So it's this red thing here is the function name. And you can call that whatever you want, again, but like a variable, if you name it something smart, then it's easier to read, and your code starts to read just like reading a book. And you get used to that. So the function name, is essentially what you want it to do. What does this function do? That's a good way to name a function. So it defines, so the declaration defines the name, the return type, and any input parameters. So that you got the name, and then in order to call a function, it might need some information. And so if you have a function and it needs information, you send it that information when you call it using these parameters. And then if it's supposed to tell you something when it's done, that's the return type. So, and this will become more obvious or more easy to understand as we actually start to walk through this. So the return type is like what, if the function needs to figure something out and say, okay, I checked everything and this was the result, it can return something. A lot of times functions will return true or false to say, I checked all these things and this was the result. Yes, the player still has bullets left in their gun. And so then the parameters are the things that the function needs to do its job. Functions don't need parameters. Some functions can run without parameters, and some functions don't return anything when they're called. But you may need to give the function something, and that will make it more versatile. Like if it's like, check if enemy still has bullets. You might want to send it the enemy, and you might also, and essentially it's like, all right, you'd call the function check enemy bullets, and you'd send it the enemy, and then it would return true or false based on if the enemy still has bullets left in their gun. And so, in between these two brackets is where all the code goes. If you're going to return something, you actually use the word return, and that spits it back out. And functions are useful for making code reusable. Again, like before, without using functions, you would just duplicate all the code inside the function multiple times, and that's not useful. So it prevents repetition. It makes something modular and separate, easier to understand, and it makes things more readable and easier to maintain. So we're going to program in C# and Unity. So actually, by now, hopefully, you're in the position where your Unity is like this. So chances are it may look something like this. If you see this over here, this URP empty template, you can click this to just remove this, because it's not really anything you need. It's just like a bunch of instructions and tips and stuff. So now we're going to just discover now if you have any problem. Like it's entirely possible. I think we actually tried to do this before, and some people had an issue getting Visual Studio to open or setting it up So we may discover problems along the way, but let's see that. So essentially, we have an empty 3D scene, and we have our project here, and we're going to create our first C# script so that it debug prints something. So a script is like any other asset that goes in assets. You know, we have scenes that has our sample scene here, settings. Let's go ahead and create a folder for our scripts so that we're organized. So if we right click on assets and we do create folder, and we call this folder scripts, so then we have a place to put them so that we stay organized. So click over here or double click so that you are in your scripts folder. So now what we want to do is we want to create our first script. So you can right click in this empty area where the folder is. And when you right click, again, you're going to go to create, just like you might create a 3D object or something or material. But here it says mono behavior script. If you click that, it'll create the script, and it's really important that you give it the right name, because the name has to match the name of the script in the code itself. So since we're going to create a script that debug prints something to the console, we're going to name this script debug print. So, and what we're going to do is we're going to use what we call camel case, which means that we capitalize the first letter D, and then we capitalize the first letter of print, P, and there's no space in between. So that's, of course, with programming, it's super important that all of the text is exactly the way it's supposed to be. You know, if something has a space or is not capitalized where it's supposed to be, you'll get a syntax error. So that's a real, you have to be really, really precise about what you do. So now that you have this script, double click on it. And this should open up either Visual Studio or on Macintosh. I'm not sure what y'all have over here. What is it that what is that called? I don't even know. Yeah, so this is going to look a little different if you're on a Macintosh, basically. But you should still have something that is similar, and the code should look exactly the same. So when you double click, that debug print script, here is Visual Studio opens up. And you'll see that at the top it says debugprint.cs. And then you have this code that is already filled in. And you see that this is a mono behavior script. And here, this name here has to match this, the name of the file here. If you were to change this name, you'd have to change that or you'd get errors. But you can see that we already have two functions that that are automatically added because they're so commonly used that Unity almost assumes that you might like to have them already there. So you see we have a function called start, and we have a function called update. And you can see that the word void here at the beginning is the return type. So void just means nothing. So this function start doesn't take any parameters and it doesn't return anything. And you see that up here, there's this text that's green is a comment. And you can create a comment by putting 2 slashes at the beginning of something. And the comment is just something that is for you, the programmer, and that the engine is going to ignore. So you could put anything you want after //space, and it'll just be ignored. All right, so we also have this other function called update. So you'll see that the comment says start is called once before the first execution of update. So this is only going to happen once at the very beginning. Update is called once per frame. So a frame, you might have heard of something like, oh, this game runs at 30 frames per second, or it runs at 60 frames per second. So a frame is like one picture created, and depending on how fast the game runs, there's a lot of them that are created. So let's go ahead and we're going to start by creating a debug print from start so that our expectation is it'll print once. So if we start typing, we'll see that this thing opens up below that. That's called autocomplete. It's kind of trying to guess what you're trying to type, and it'll start to fill it in. So if you actually see what you want and you hit tab, then it will complete it. So tab is that button above caps lock on the left-hand side next to the Q. So debug is the first word, and then if you type a punct period, then L, you see log, and that's what we're looking for. You can again hit tab. Now you need to do a parentheses, and you see, parentheses like this. When you type the first one, it'll automatically create the second one, and it's already telling you essentially, because well, for one, you need a capital L for log, and I think that it's the color is slightly different because of the editor that you're using. Different. So you Macintosh people, you're not using Visual Studio because it's a Microsoft product. You got something else, but you get a lot of the same stuff, but it might look slightly different. But yeah, but you can see here, this autocomplete is telling me that, like, okay, the command debug.log with a message logs a message to the Unity console. And there's actually two different versions of this. And if I click down, I can see that I can either have object message or object context. But what we need in here is, if we start by putting a, what is that called, quotes, and we say, hello, DNA. So it automatically created another quote. So we're typing in between. Now if we hit tab twice, actually, no. You actually, I think you might have to use the arrow keys to get to the end. What we're missing is a semicolon. And once we type that exactly as it is here, the red squiggle goes away. If you see red squiggle here, that red wavy line at the bottom, that means something's wrong with your syntax. And you need to look really closely. It could be a capital. Maybe you have a lowercase where you have a capital. Maybe you accidentally put a colon instead of a semicolon. But as long as you see red, something's problem. But now, debug.log and our message. Now, you might think, like, yeah, when am I ever going to use this? Actually, you use debug log statements a lot. Anytime you want to know if the code is executing up to a certain point. So this is one of the most useful things that you can do when you're running your code to understand if it's executing correctly. Now, what's really important, there's a star up here, and that means that I haven't yet saved my changes. So if I switch over, none of this will actually run correctly. So you have to save. So make sure that you don't have a star up here. Make sure that you've saved your work. And so now when you switch back to Unity, it'll probably take a moment to, you'll get this reloading thing that's basically telling you that it's building your changes. So that's totally normal. So, when you make a code change, a lot of times it takes a second. But when you come back in here, you shouldn't see anything, in the console that's red. In fact, now that, since, the debug log statement that we just made is going to print to the console. So let's drag the console so that we can see it. So instead of it being behind project, let's drag it over here next to it. While we're at it, let's drag the game window to the side so we see both the game window and the scene view. So if we set it up like this, we can see the scene, we can see what happens in the game, we can see our project, and we can see anything that happens in the console. So we'll know if there's a problem. No problem. Oh, it looks like you're. It looks like the game window is floating.
Yeah, it's floating.
So I think that you need to drag it until it snaps over here, and then you'll have it.
Yeah.
Mm-hmm. Oh no, no worries, no worries. All right, so okay, we created a script. Okay, cool. Like, let's run the game. Let's see the script work. Click pause. Click play. What happened? Nothing happened. Exactly. And that's because a script that's in your project isn't yet in your scene, and you need to attach it to an object in the scene for it to run. So the only thing that happens when you run are the things that are here in the hierarchy. So what we want is, if we want this, this script to run, we need to attach it to something in our scene. And so let's right-click in the hierarchy and create an empty game object and call it just like debug. So now we've got an empty object here in the scene. There's nothing on it. It just is, all it is a transform. No, when you right-click, just click Create Empty, which is right above 2D object. And that can be really useful. There's different things that you might just want a empty game object that doesn't have anything attached to it, like an invisible marker in the world. So if you create empty, and then you name it debug, then what we want to do is we want to take our debug print script here, and if you drag it over and drop it in the inspector, it'll add it there. So let's see, I'm going to peek at my presentation just to see, okay, so we looked at that, we added our mono behavior script, and we put in our debug log. We know that we know how red squiggly is bad. We noted that, like, if you don't attach it to something in the scene, it doesn't actually run. And so we created this thing. And now that, yeah, I just dragged it from here to here. Mm-hmm. Mm-hmm. Oh, you need to, let's see. Oh, well, you don't have an object there. Mm-hmm. Create empty, debug. And now click on it, and then drag here to here. Mm-hmm. No problem. So, so now that our script is actually attached to an object in our scene, we can save our scene, make that star go away, and then if we play, we'll see that it printed to the console. And so that's what we expected it to do. So you'll note that when we dragged and dropped our script onto our object in inspector, it added it. And so scripts act like other components. We've put components on things like box colliders, like something that is like the camera has a camera component, directional light has a light component. A script is just a component. You can create scripts that do different things, and you drag and drop them onto game objects, and that's how you give a game object the ability to do something. You can think of scripts and components in general like verbs. Like, now you can jump, now you can run, now you can do this. So you give things that opportunity. So let's see. So we have tested our script, and we saw it tested a debug print. Now let's let's try something a little different. Let's go back here and say, okay, well, what would happen if we go back to our debug print script, and if we take this out of start and we do we cut it, and then we go to update and we paste it. So what we did was we just cut and paste from start to update. Now we hit save. So if you do that, you know, you'll see it, and it'll take a second for it to load it up, but then when you get over here, you can imagine what might happen. So now, instead of just once, we're constantly getting this debug print to our console. And it's happening multiple times a second. So that's the difference between start and update. If we put something in update, it's going to happen once per frame. Whereas if we put it in start, it just happens once before the first execution of update. So if you want something to happen just once at the beginning, you put it in start. If you want it to happen every single frame, you put it in update. Cool. So now, let's take this a little bit further. All right, so you can click clear to make your console clean. Now if we, in our sample scene, we can go ahead and get rid of this global volume because we don't really need it. What we're going to do next is we are going to create a sphere and have it move every frame by using a command called transform.translate. But first we need to set things up a little bit so that we can see it better. Was it? Oh, how to stop it? Click, well, I mean, actually, once you click play button will change to a square, and then click the square to get it to stop. So then you can stop your, all right. So let's see, actually, let's do one thing before. Let's practice using variables. Because we can actually use a variable instead of hello DNA, I can actually, let's create up here above start. So inside of inside the brace for this class, but above start, type the word public. And then type string, and then type name. Name is going to have a green squiggle under it. That's okay. So now we created a variable called name. And we've said that variable is a string, which means that it's a word. And public means that we can see that in the Unity inspector. Now, let's go ahead and leave it here in update. And let's say, okay, we're going to say hello. Let's delete the name and just have hello space. And then outside of that quote, do a plus and then name. So essentially, and then, so what we're saying is, in update, we're going to print hello plus the name. However, we haven't yet assigned a value to name. So let's do that and start. We can say name equals, not JetBrains, name equals, and put your name in here, and a semicolon at the end. So what happens is that this string, the variable string, we'll be able to see it in the inspector in Unity. When this thing starts, we'll assign name, the value of Brian, and then on update, it'll say hello space plus name. So then save it and switch back to Unity. So it'll take a moment. It looks like, let's see, use the new keyword of hiding wasn't it? So interestingly, so there is a warning that comes up, but that's okay. Let's ignore that for now. But what you will see a change in the inspector. Now there's something that says name here, and it's available here. It's a variable, but it hasn't been assigned my name yet because that won't happen until start runs. So now let's press play and watch what happens. So when it starts, name gets the value of Brian. And that's because that happens here in start. And then you'll see in the console, it's printing out hello, Brian, over and over and over again. Mm-hmm. Yeah, what's up, Benjamin? All right, let's see. It says, yes, it expects a semicolon. So if you go back to your code, you need a semicolon at the end of name. Exactly. Mm-hmm. And that's where the squiggle was giving you the hint. So yeah, everything has to be exact with programming. So you're gonna get used to looking for that squiggly line. In fact, if there is a problem like a missing semicolon, like Benjamin was experiencing, not only do you see a red squiggle here, there's also red indication over on the side. If you have a really long script, that can help you find where the problem is. So red bad. And so if I switch back, and it's because update is constantly printing hello Brian, and it filled in this at start, but I can actually change that to say hello Benjamin. Now it starts printing hello Benjamin. Let's see. Well, you have to get it start it first. Mm-hmm. And so then when it starts, it'll get the name and we'll start printing. Let's see. Oh, if you already have something in the name field, that actually winds up overriding anything else. Mm-hmm. So yeah, so exactly. If this isn't empty, if you put something like Jesse in here to start with, it'll actually be a value that overrides the value that's set in start. And you'll only see hello Jesse. So that was what Benjamin was experiencing. Oh, actually, no. I had it in there first, and then Jesse was there, but then Brian overwrote it. But if I put Jesse now, it'll switch to that. So you'll see that you can change the value of a variable while the game is running. Mm-hmm. All right, cool. So what we should do now is let's stop the game. And so we've seen that we can, by putting this public name in front of a variable, public type of variable, name of the variable, that means that variable will be something that we can mess with here in the Unity inspector. So if I were to actually take away public, then now you won't see that after it compiles, it will no longer be something that you can see here. So, and that, when there's not something in front of a variable like public, it's automatically private. So you could say private, but if it's not there, this is the same thing as this. So something's not public unless you tell it to be public. So if you want to expose things to tweak them in the editor, then you have to say public. All right, so now we're going to move into the next step, which is to actually do something more than just working with the console. Let's make things happen here in the scene and in the game itself. But to do this first, let's set up let's set the scene up a little bit. So let's see. I think that I actually should have. So I talked a little bit about frames and frame rate. So we're going to do some simple movement. And in order to do this, what we want to do is we want to set up our scene so that we can see something. If we didn't put a ground in, it would be hard to tell if something's moving. We need a frame of reference that'll help. So let's set up a cube that's 20 by 0.1 by 2. It doesn't have to be precise, but the point is, here in our scene, it's going to be hard to see movement without a frame of reference. So let's right-click and do a 3D object that's a cube and name it ground. And then it created it in a kind of a wonky position. So the first thing we'll do is reset the transform. So it's at 0, 0, 0. And then let's make it 20 in the X. And then something small like 0.1 in the Y. And like 2 wide in the Z. So you see, we've kind of got a runway, like you're a fashion model. All right, so fashion models, they walk down the runway, turn around, walk back. So we're creating a runway for our sphere to walk down. So you should have your ground set at 0, 0, 0, 20 unity units, meters long in the X. So we're going to have something move in the X direction here. So now that we have our ground set up, let's add a 3D sphere. And you can just let that be named sphere. But again, depending on where your camera is, it might put it at a kind of a weird position. So let's just reset that so it's at 0, 0, 0. And then let's move it up in the Y position by like 1. Actually, we could probably do even less than that, like a 0.4 maybe. So let's see, maybe a little higher, maybe 0.6. All right, so that is just above our runway. Our sphere is going to walk down our runway. You'll note that we have a camera in this scene that is allowing us to see this from the side as well. So we should see it move in this direction as well as we should see it move in the game. Now, we don't need this debug object anymore, and we know it's going to fill our console, and that might be problematic. So let's just get rid of the debug object. So our scene just has the camera, the light, the ground, and our sphere. So we can save it. So now we're going to create another script. Generally, you want scripts to just do one thing. So we're not going to add this to our debug print script. A debug print script is just debug printing. So let's create a new script, and we're going to call it move. Because we might want it to move, we're going to have it move our sphere, but we might want it to move other things. So let's anticipate that we might want to use this for other things. And so here we right-click, you create mono behavior script, and call it just move. Simple. Move. And if we hit enter or double click it, it'll open it here in Visual Studio or whatever IDE you're using. IDE is the development environment. It's the tool that you are coding in. All right. So we want our sphere to be moving continuously. We don't want it to just take one step and move once. So we're going to put this code in update. So let's see. In fact, so what we're going to do is we're going to use this, this command. There's a lot of commands that are built into Unity that you can use. And the one that will move things is called transform.translate. And so essentially, we're going to write this code here. So if we go to update, since we want it to run every frame, so the thing that we're moving is a game object. And so that's why we start by saying game object. If you type the word game, you see game objects at the top. You can just hit tab to autocomplete. You'll notice that it's lowercase at the beginning, uppercase O, and that's important. You'll learn the distinction between why some things are lowercase and why things are uppercase later. But what we're saying is, okay, the game object that this script is attached to, look at its transform component and then translate it. And you can see that it will, the command translate will move the transform in the direction and distance that's specified. So then when you do a parentheses, there's 6 different ways you can specify what you're looking for. And what we want to do is we're going to do, this one, that's float X, float Y, float Z. You don't have to click this. It's just kind of giving you information about the different ways you can use the translate function. But we want to go 1 in the X, 0 in the y, 0 in the z. And then go to the end and put a semicolon. And it cleans it up a little bit by adding spaces in there. So it translates every frame, it'll translate, which means to move, this game object's transform 1 unit in the x, 0 units in the y, and 0 units in the z. And so now we'll save this. So if you did this right, if everything looks correct, there should be no red squigglies. And make sure you save it before switching back over. And when you do, it might take a sec to compute. You can clear your console if you want. You don't have to. It usually clears automatically. Now, just like we learned, that script doesn't do us any good down here. We need to attach it to the game object that we want it to work on. So if we click sphere, we have all of these components. It's going to be easier if we collapse them down. Actually, let's leave the transform one open, but these other ones we can close, and then we can drag move onto here. So now you have your sphere. We can see its transform to know if it's working. We have our move script attached to it. So if we press play, what you should see is you should see your sphere move. And it moves pretty quick. Although, even though it flies off the screen, you can see that it transformed, that X is still moving. You have an issue, Jesse? Mm-hmm. Let's see what you got. Oh, let's see. So you have move, and you created your sphere. So you can collapse these down just to get them out of the way. Now drag this to here. Mm-hmm. No worries. That's what we're here for. So once your script is attached, you can see, yeah, this thing is moving, it's translating on and on and on and on and on. If you just let it run, it'll keep going. And you could actually click on the sphere and here in the scene, press F and zoom in on it. You might even be able to watch it go off into the deep distance. Bye-bye. Later, sphere. But then when you stop, it goes back to the original position. So there's our sphere. So, but if you think about what we did with that debug print, we can do the same with our sphere, and we can expose the value that it's moving to something that we can access here in the inspector. So if we go back to our script, instead of just telling it to move 1 over and over and over again, let's make that a variable instead. So let's create a variable. Now, if you look at this, it says translate float x, float y, float z. There's different kinds of numbers. One is an int, another's a float. There's also a long. So the difference is that an int, so if we say int number, and we try to give it something like 1.2 or 1.3, it won't let you say, this is wrong, man, because an int is just whole numbers. 1, 2, 3, 4. It could be, negative 12. As long as there's no decimal place, it's an int. A float is anything that has other number equals, like, it can be 8. Let's see, float other number equals, why did you not like that? Oh, is that a double? No. Putting an F at the end forces it to be a float. It was thinking that that's a different number. Okay. Let's see, delete, does that work? Yeah, nope. Literal of type double command, yeah, exactly. If you put an F there, you'll force it to be like, no, I mean for that to be a float. So if we try to take this number here and put it here, it'll probably say, well, actually, I think it's implicitly translating that to be a float, like negative 12. So generally, what we want to do is we want to say float speed equals, just give it a number like 1. And so then we can say, use speed as the value that's translating. But remember, if we want to be able to tweak that number in the editor, in the inspector, we want to make it public. So in the end, we have public float, name of it is speed, and we initially set it to 1. We could set it in start, we can set it here when we define it, but the point is we're actually going to adjust that as it's running to see the effect. And so now we use this variable here as our instead of the value 1. We've set it to 1, and it'll start at 1, but then you'll see when we save it and we switch back. So now our move script has the value speed here. If you put your cursor over speed, you see you can actually adjust this number up and down. But if we start with the value 1, and if we play, it'll start and it'll go just as fast as it did before. But we can actually make it go negative and it'll come back. And we can make it kind of bounce back and forth by switching between negative and positive. And we could find the exact value that we want in terms of a good speed. So it's like, oh, okay, if I put it really low, like 0.4, it's moving kind of slow.
I don't know why I stopped all these objects gone. The sphere and my cube all gone.
When you stop?
You remember here was this, and then this debug came back.
That's weird. Did you control Z by chance?
No.
Let's see
I
if
just stopped and all gone. All these two.
Oh, I wonder if it's possible that you did all that while the game was actually running. You see, if the game is running, this is why I've set mine up so that it is green colored. You may not have realized that the game was running, and if you create like a 3D object, like a cube, you can do that now. And you can make all these changes. And then when you stop, it goes away. So that's what happens is, so something that Jesse discovered is that you might have noticed that when I play my game, my whole screen turns green. And that's a setting you can set up in preferences. And you see, and that's because without that, what Jessie didn't realize that she was in play mode and you created things, and then when you stopped, they all disappeared. Anything that you change, including creating things and adding things, goes away when you exit play mode. And so, yeah, what I recommend is if you go to, let's see, go to Edit, Preferences, and if you go to Colors, there's Play Mode Tint. And you see, you can set this to any color you want. I set it to green because I find green to be a pleasing color. But yeah, if you go to Edit, Preferences, find Colors over here on the side, and change Play Mode Tint to a color. If you click it, you get this color picker. You can pick any color you want. So if I were to say, like, okay, I like fuchsia instead. Now, when I press play, my whole Unity turns to fuchsia. For me, that's a little overkill. So instead, I'm going to do preferences. I'm going to change that colors, play mode tint to green. Because to me, that is more of a like optimistic, like, yeah, I really hope this is going to work. Green. But you can make it whatever you want. And you can make it, as long as you kind of, make sure that you are aware of what's happening. All right, so now we have a sphere that moves at a given speed. So what you kind of want is to find a speed for this sphere that, is something that doesn't fly off the screen way too fast. Find a speed for the sphere that moves at something reasonable. So if I have it come back, let's see, I'm going to estimate if I go like, okay, I know 0.2, actually 0.05. Let me try that. You can start it, stop it, start it, stop it. Just if you're changing it while it's going, just remember that value. So I'm like, okay, 0.05 means that it's not moving so fast that I lose it immediately. So, all right, cool. So you might even speed this up a little bit if if you're imagining like, well, what if this is like a bullet that you're shooting out of a gun? Or maybe it's maybe better to think of it like a rocket that comes from a rocket launcher. It moves, not too fast. So maybe let's rename sphere to bullet. So let's pretend this is a bullet. Yeah, Benjamin.
How do you make acceleration so it accelerates?
Okay, gotcha. So in other words, you would want to be changing the value of translate as it's going. So Benjamin was asking like, well, how can I make it accelerate so it starts at a speed but keeps increasing? You're getting a little bit complicated, which I like. But the point is, speed is going to stay constant. Now, all right, so let's see if we could do this. Okay, so if you said speed equals speed plus the amount that you want it to increase each time. And you might need to put an F there. So this will create acceleration. This means that every frame, it'll start out at 1, but it will gradually increase. Yes, F for float, exactly. So that would create, a ever increasing speed. So of course, and you could also turn that into a variable. So you could say, okay, public acceleration equals, give it a starting value. Acceleration, and it's barfing because it wants an F. Oh no, it's because I didn't put float. So, yep. So now if I were to replace this here, so I start out with the speed of 1, but every time a frame occurs, it's going to translate it by that amount, but then increase the speed by the acceleration amount. So now, when I go back here, because both of those values are tweakable in the editor, what's nice about that is I can get what I want without having to go back to the script every time. So for example, like, it should start out, for me, I'm starting out at a fairly low speed, but I should notice that acceleration. And it goes, zzz, and you can, if you really want to get a sense for it, watch the X value of position. This number here of position of this bullet is going to start going up faster and faster and faster and faster. I mean, there's even ways to have this based on a graph that you create. There's ways to make this a value that actually is a graph that you can see and to tweak the graph rather than adjusting the numbers, which can be pretty cool. So that's a cool addition. All right, but let's say, all right, so you renamed your sphere to bullet. Let's say that, we want to create a rocket launcher that shoots these bullets. So if we want to create something over and over again, what we first want to do is we want to turn this bullet into a prefab, something that we can create that exists in our project as a project asset. Are you following, Jesse? Any issues? So where you want to be is you want to have named your sphere to bullet, just because sphere is kind of weird. You don't need the acceleration and all that stuff. But what we want to do, in assets, we want to create a new folder, create a folder called prefabs. Again, we're trying to be organized here. So when you click on prefabs, it's empty. Now, if you drag bullet from the hierarchy down to the project and drop it in here, it creates a prefab of the bullet, and bullet in the scene turns blue. But you'll see, like, now you have this prefab, a thing that you can create over and over again. That's a sphere that has the move script you created already attached to it. And so if we take and select the bullet here and delete it, we still can have access. We can create bullets and have them appear up here. In fact, maybe we want to. So what you do is, let's take a look. So let's see. So you have your bullet up here, and in order to make a prefab, you click it here and you drag it and drop it there. So I'm going to let you do that. So if you drag bullet down there and let go, so it creates a bullet prefab, and bullet up there turns blue. So what we're thinking to do is we're going to create. Let's imagine we're creating like a turret that sits there and shoots these rockets, these bullets. So let's start by creating another 3D object that this is going to come from. Let's do a cube, and let's name this, turret. Turret works better than gun because a turret tends to be something that sits there and doesn't move. Again, the transform is probably slightly weird, so reset it. And let's, this time we can use the move tool to just bring it up a little bit so that it doesn't sit on our, so that's above, more or less sitting on top of our ground. So cool, we have a turret. So a turret is something we're going to use to spawn bullets. So for example, if I go back over here, we set this up, we created the sphere, we talked about variables, and made it so that the sphere could move. We were able to see this this object moving back and forth based on changing the move amount. I warned you about exposing variables and stuff like that. So now we're moving on to spawning and despawning. So spawning is creating something, like creating a prefab. So, in here I called it spawner, but instead what we're going to do is, using game object instantiate. So our turret needs a script that will allow it to create things. So, we could create a script that is, for example, create mono behavior script that is shoot bullet. So anything that we want to shoot a bullet could use the script that we're going to create to do so. So let's see. Sometimes it automatically jumps over to. So in scripts, I created a script called shoot bullet, capital S, capital B. And if I double click that, it opens up here in our IDE. And so what we need now, we need a way for this script to get and grab a bullet. We need to give this script access to be able to know what a bullet is. And so we're going to do that by creating a variable that is a game object. The bullet is a game object. Just about everything in Unity at the very top level is a game object. So we want to assign it in the editor. So we'll do public game object, capital G, capital O, and name it bullet. So we created a public variable that can be accessed in the editor. The variable type is game object, capital G, capital O, and we named it bullet. In this case, it's because this is a proper thing. For example, there's a difference between little g game object, which means the game object that the script is attached to, an instance, versus this is the idea of, it's a type. So just like we use, and I imagine that could be a little confusing because previously int was lowercase, float was lowercase. But in regard to a specific object that is a type, and this is something that seems inconsistent, but you'll just use it and get used to it. So public game object bullet will allow us to get a reference to something. So now what we want to do is we want to spawn these bullets in update because we want it to shoot kind of like a machine gun. Pew, 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 pew. So let's say game object dot instantiate. So the capital G, so this is a specific command in Unity that's very common. Game object dot instantiate. And if we hit the parentheses, there's different ways to do this. We can give it the object. We can tell it where, transform parent, etc. This tells us all the different ways. There's so many different ways to do this because it's a super useful thing. But for now, let's just say we'll do Control C to copy this, Control V to paste it, and we'll put a semicolon at the end. So what this should do is once per frame, it's going to instantiate a bullet, and it knows what a bullet is because we're going to assign that in the inspector. Yeah, Benjamin.
Instantiate spawn.
Yes. Instantiate is a word for spawn. Those are synonyms. They mean the same thing. So yeah, they could have called it gameObject.spawn, but they're being like kind of like, no, we're going to instantiate, which is just the exact same thing. So if we save this and we jump back to Unity, it's going to take a second to compile. So now we need to attach this to our turret. So if we select turret, we can collapse down the other components so that it's easy for us to drag and drop shoot bullet here onto the object in the inspector. Yeah, Benjamin. Mm-hmm. Yeah, oh, you need a capital I.
But I do have
All right, let's take a look. Game object dot instantiate bullet. Oh, you did game object space instantiate. You need a dot in between, a period. So yeah, like commands like that tend to be like you can almost think of it when you see something that's like game object dot instantiate, like when you see these dots, in a way, what you're saying is like instantiate is a command that applies to game objects. So a lot of times, so that dot is how you essentially say, look in the library of all the things a game object can do, find the thing that it can do called instantiate, and that could even be like, you could be something dot something dot something. It's almost like an address that lets you find something. So now when we go back, you have the turret, you have this shoot bullet, but you need to assign the game object that you want it to instantiate. And what we want it to instantiate is the prefab of the bullet. So if we click in our assets, go to our prefab folder, you can drag this bullet here and drop it there. And because this is the right type, it allows you to do that. So you want to drag your prefab of the bullet into the variable field for bullet in this script. So you can also click this target here, which opens up a window, and you can select it that way. But drag and drop is something most people just get used to doing instead. So do you have bullet there? Okay. No, let me take a look. All right, so let's see. So you haven't yet put your script on your turret. So you have to go to your scripts. So if you shoot bullet script, and you have to put the shoot bullet script on it first. And then you can go to your prefab and drag your bullet into there. There you go. So you can think as like first you're giving the turret the ability to shoot, then you're telling it what to shoot. So now let's see if that works. We can save. And what we should see is we should see bullets getting spawned here, and then the bullets start moving. And it almost looks like they're sitting still, but actually each one of these bullets is moving. For example, we can see that as transform change. So if you look here in the hierarchy, you can see that the turret has spawned all these things that say bullet clone. And each one of those, if you click on them, is moving in the X direction. And they just keep spawning and spawning and spawning and spawning and spawning because nothing tells them to stop. And so it almost looks continuous. But for example, one of the things that we could do, yeah. So show me.
Shows there.
All right. Let's see. Where did you attach your, so is your turret, does that have your shoot boat script? Okay, gotcha. And then let's see. Oh, if you go to your prefabs, click on sphere. All right, so you have your prefab is spawning at this unusual position. Try zeroing that out. So Benjamin, in his prefab, the transform for that was set differently. And so that's kind of like relative to the, all right, so now you're getting, oh, it looks like, all right, so if you click on turret, so yeah, you need to reassign your bullet there. So drag your bullet into there. There you go. There you go. And you know, it might look like a snake that's gradually forming. Well, if you click on the bullet, you know, if you go to your project, you can click on the bullet and you can see its properties here. And the move script has a speed. So for example, I'm going to zero out my acceleration. I'm going to slow this down to like, I mean, it's like 0.1. You can set your speed there. So so that's a good point too, is that you can make changes to the properties in the project for the bullet. And when you spawn it, it will have those properties. So for example, like, you know, I made it so that my bullet no longer accelerates and has a speed of 0.5. And so it looks kind of like a snake. But if you click on any of these, you'll see that they are moving. They're spawning so fast that it seems like they are actually moving really, really fast. So actually spawning in update is kind of a bad idea because it's spawning so fast. So let's try something different. Like we can, instead of spawning these bullets in update, we can use a different command and we'll create a function to do this. So let's create our first function. And generally when you're creating a new function, you might put it below start and update. So let's create a new function. It won't return anything, so we say void for the return value. We'll call it spawn bullet, and then we will take the game object that we want to spawn. Actually, no, that's not. So we'll do void spawn bullet, and then we have to put a bracket here. It'll create two brackets, and if you hit enter, it'll do this. So basically, okay, let me go through that again. You type void spawn bullet, open then close parentheses, click one curly bracket, it'll create the other one automatically, and if you hit return, it'll clean it up and make it look like this. That looks good. Oh, you having trouble with the keyboard? Oh, okay, no problem. I feel your pain. Yeah. So let's take our bullet out of, let's take our command out of update, and let's cut it there and let's paste it into spawn bullet. So as this stands, it's not going to spawn anything because we're not calling the function. But what we can do, there's a way that we can call a function and control how often it's called. That's a different, and so it's a different command, and it's called invoke. So if we go to start and we type invoke repeating is what we want. So you can see it says invokes the method in time seconds, then repeats every seconds. So if we type invoke repeating, parentheses, it takes the string name of the function, which is spawn bullet, and then how long should we wait before we start? You can say wait a second and spawn every second. So in the end, in start, you're calling the function, you're calling the command invoke repeating. And invoke repeating says, tell me the name of the function you want me to call as a string. So you put it in parentheses, comma, how long to wait before it starts, and then how often it repeats. So now let's save that. So this is going to give us more control over how frequently it spawns. When we put it in update, it's called once per frame, and that's a lot. We don't want it to shoot that fast. That's too crazy. So now if we switch over, we let it compile. When we click play to start, it should wait a second and then it should spawn a bullet every second. So depending on how fast your bullets are moving, you know, I can actually even change this now if I wanted to really slow it down to 0.1. This is something that actually, if I make a change to the bullet prefab of the project, it will stay when I stop. So you can see, now we're telling the move script to move at this speed, and our turret has this spawn script that's spawning bullets. You can even move this turret up, and it doesn't change. I guess, yeah, it still kind of cached that position. Probably because of the. All right, so now of course we can change. We can actually convert those these frequencies to being variables themselves and control that. So I would recommend, like we're a little over time for a break. We'll take a little bit of a break, but something that you can do in the meantime is just like in the move script, how you use variables to control this command translate, you can use variables to control how long the delay is before it starts spawning and how frequently it spawns these bullets. And you can change that, you can tune that to however works for you. So feel free to take a break. Well, that looks like a frame rate stutter.
These two are like close and then another one. See?
Yeah, let's see. I think that I wonder if we can show stats. Okay, so if we look at the FPS, so you see how that number is moving around a lot? Is your computer kind of old?
No, it's just 3 months ago.
Okay, because what happens is every once in a while your frame rate, you see how that number starts out at 40, but every once in a while it dips down to like 17 or 14. That change. And what's probably happening.
It's not a good computer, right? I mean, it's a work computer. I don't like it at all. Just they told me it's a very fancy computer.
Well, actually, what we're going to learn next is, all right, if you allow your computer to just keep spawning things that are moving, the longer that goes on, it's each sphere that you spawn is using some resources, and so it keeps it's like if you were trying to carry something and I put a rock on top, then I put another rock on top, and then I put another rock on top. Your computer is eventually going to start getting bogged down and slower. This is something that you really don't want to do. Is, when people, if you're playing a first-person shooter, they don't just continuously spawn bullets endlessly and have them move through the world endlessly. You need to, if you're going to spawn something, this is a very good point. If you're going to spawn something, you need to decide when you're going to despawn it. If you're constantly spawning and never despawning, then you're just going to slow your computer down and down. And even a strong computer will eventually get to that point. So that's actually not unexpected. What we need to understand how to despawn in order to prevent that from happening. So actually, there's that. So what I'm going to do actually, what I would be teaching you next is essentially, so we did invoke repeating, and this is actually what you're experiencing. You could spawn until your computer crashes. If you spawn enough stuff fast enough, you'll eventually choke your computer. There's physics games where you can spawn endless things and eventually they like chug and crash. So you need to learn how to despawn. And so I want us to get to the point about triggers, but another thing you can learn is how to despawn. And that's something that you essentially, actually, let's do this. We'll actually get to triggers. This is valuable stuff to learn, and we'll get to triggers during the animation class. So yeah, I do think that we should figure out how to despawn because it's actually going to involve a condition, and that's useful to know. So 5-minute break, and we'll be back. So has anybody ever played one of those games when you can just endlessly spawn something? Like, for example, there's Gary's Mod, or other games. I'm trying to think there's several games out there where you can kind of play around with the engine, but you can also push it so far that it eventually chokes even like a fast computer. I know in the game Teardown, which is a really cool destructible game, it has like a level editor or an editor where you can have a creative mode where you can build things and you can spawn things, but because they're all physics enabled, it isn't hard to take even a good computer and bring it to its knees until the frame rate just drops to virtually nothing. So that is it's pretty common. All right, so now to be responsible game developers, we're going to learn how to despawn. Because as I mentioned, just as you noticed, Jesse, like you can spawn so much that every one of these spheres that you're spawning is taking up some amount of CPU resources. And if you don't get rid of them, then you'll actually cause a performance problem. And one of the things I showed Jesse was that you can actually look at this. If you're looking at in the game view, you can turn on stats and it'll show you your FPS. So for example, if I get started and I watch, I'll probably see a little bit of effect as I start. So I start really high because this is a pretty fast laptop remarkably. But then if I were to say, okay, what if I go back to this and well, it's actually the speed shouldn't be that much of it, but the amount spawned. But you can already see that the FPS every once in a while starting to go a little down. And if you were to go back to, if I were to spawn, let's see, every 0.001 seconds, and switch back, like I will probably notice, because that's essentially saying like spawn much more frequently. And so now when I hit play mode and watch the statistics in the FPS here, all right, so now you see, yeah, it's not running at 100. It's starting to feel the effects. And the more of these, you will eventually start to see it going down a bit. It's a little up and down for a while, but because you're not despawning, then it keeps building up and building up. And it's not hard, especially you can imagine if you're creating like a shooter game and you're spawning bullets and not despawning them, eventually the FPS is going to drop to the point where players notice it and it's really bad experience. So let's make sure that that doesn't happen. So I can hide that stats thing again. So let's be responsible developers and despawn things at a point when they're no longer useful. And so this is going to be a new script. And let's see, what did I wind up calling this script? I wound up calling this despawn on distance. So if we right click and do create mono behavior script, I mean, we can call this despawn on distance. Did I get that right? Despawn on distance, yep. You might have scripts that use different criteria for despawning. You could just call it despawn if you wanted, but then you might have something that despawns on distance. You might have something that despawns when it hits something. You might want those to be separate. You could have them being the same script. So I called this despawn on distance because I know that it's specifically going to do just that. So this is a script that we're going to attach to our bullet to know when to despawn. So we create it. And so, what we're thinking is like, before we go into writing the specific script, we're thinking like, okay, we're gonna know that it spawned at a certain point, and that as it spawns, it starts at x equals 0, and that number x goes up and up and up and up and up as it moves. And that at a certain point, we'll look at the current x position, and if it's greater than the max distance that we want it to go, then we're gonna despawn. Like if you kind of figured this out in advance, this is called pseudocode. You're not writing it formally in C#. You're just saying like, okay, I'm thinking this out, and the way that I want this to be written is like this. It's kind of a shorthand for writing it. So what we'll essentially do is we'll want to check every frame if this bullet, this particular bullet that we just spawned, has gone a certain distance, and we'll test it using an if statement. So essentially, we're going to use current x position and max distance, and we'll make them public so we can watch them in the editor and see. So we'll do current x position and max distance. So at the beginning, public float current x position. And that's something that we don't set, it's something that we check. And so then we do public float, what did I call it? Is it despawn distance? Called it max distance. Max distance. And we could give that a starting value of 10. And so we're going to have these two variables, current x position and max distance. And we're going to want to check them on a regular basis, and we can use update for that. That means that every frame will check this. And the way to check something is to use an if statement. We're going to say, if this is the case, then despawn. So we can say, if current x position is greater than max distance, then despawn. And I haven't figured out what specific command I'm going to use for despawn is yet, so I just put a comment in there. So essentially, in update, if parentheses current x position is greater than max distance, then we want to despawn. All right, so now we have to figure out, well, how are we going to, what's the command for despawning? And so it turns out there's a command called gameObject.destroy. It's kind of the opposite of gameObject.instantiate. So we can say gameObject.destroy. And it's like, okay, we need to give it the game object that we want it to destroy. And we want it to destroy the game object that this script is attached to. So we can say this.gameObject. We don't need the this, but it kind of helps. It'll actually understand it if you just put lowercase game object. So this is the difference between game object here is the library of things available to the type game object, whereas lowercase game object means the game object that this script is attached to, the specific one, the instance. So now we have a script that we can put on our bullet that every update is going to check, and if the current x position is higher than max distance, it'll do gameObject.destroy. But the problem is we don't know what current x position is. We need to get that first and update it, and we can do that right before we check it. So we'll update the value of current x position and say this.gameObject.transform.position.x. And that will say, that's how we say. So in other words, if you check this now, current x position hasn't been given a value. This actually won't evaluate correctly. First, you need to figure out what current x position is. So current x position equals this game object's transform position x value. So we're talking about this game object. We're looking at its transform component. We're looking at the position, and we're looking at the x value, which is the same as, for example, everything has a transform component. It has a position, and it has x, y, and z. So you're saying, I want to look at specifically this, and that's the address. If I want to know the current x position of this game object that this script is attached to, I say game object transform position x. So no, it doesn't stop it moving. It literally, so you know how shoot bullet did gameObject.instantiate. That created something that wasn't there. So gameObject.destroy is going to remove something there. It'll literally, like as we were, as turret creates game objects, they appear here in the hierarchy because they're created. Now we're going to use the destroy command to literally remove them from the hierarchy. So it's the same way that, like, you know, I don't want to get biblical, but like God creates the world and then destroys the world. Like you're God here. You can literally use scripts to create things that aren't in your scene and then destroy them. So you can create a bullet and then destroy the bullet. Like if I have a bullet and it hits my enemy, I probably want to destroy both the bullet and the enemy because, you know, now I've done what I wanted to do with the bullet. If I were to just destroy the enemy, the bullet would still be there and still keep going. And so we want to destroy something when it's no longer useful to us. All right, so now, so we have, we've created despawn on distance. We have used update to get the current position, test if it's greater than max distance, and destroy this game object if that is the case. But it's not yet attached to our bullet. So what we need to do is the bullet prefab, we want to attach this, this new script that we just created to it. Now, if we switch over to scripts, we can collapse this and we can drag despawn on distance here. Now, if you, for any reason, if you have trouble doing that, you can actually add that, you know, use add component to do the same. You can look for despawn on distance and you can search for it and find it there. So now we've made it so our prefab bullet, which are created, will despawn themselves when they run a test. Each bullet kind of has its own intelligence now. We gave a bullet the ability to check where it's at and despawn when its distance has gotten to a certain distance. Mm-hmm. So let's see. So go and select your prefab first. Click the bullet. Now go to scripts. Now drag that here. So I think Jesse is experiencing this thing that's not at all uncommon, which, like, sometimes if you have all of these things open, and especially if you have this thing open as well, there's kind of no space to drag this onto. You see, it's kind of, you can get it to, like, if you get it to here, then it'll work. But that's why I will hide this and I'll collapse these other components to give myself a little space. But that's another, actually, that's why I showed you how to do add component instead. You know, you can drag and drop this over here, or you can find it in add component and click it. So that's another method. Sometimes it's easier to use add component than it is to drag and drop. Yeah, if you do, so if you have your prefab selected, and so for me, like I'm going to go ahead and just remove this so that I can show you. I have my prefab selected. When I click add component, if I type, you know, because if I don't start typing, there's tons of components. I need to search for despawn on distance, and then I find it and I click on it and I've added it. So now your turret, when it spawns bullets, the bullets should go 10 meters and despawn themselves. So now, and you'll see this. So you see that, you know, if I click on any given bullet, it gets to this point and then despawns itself. Now there's a steady stream of bullets being created. But any given bullet, once it's gone to the max distance that I set, despawns itself. So if you zoom out, so you see the point at which they stop spawning. So your camera in your game might not show this. So you might have to actually zoom out your scene to see this. But of course, you can change the distance. If I click bullet, I could change this max distance to be smaller. Actually, if it's negative, that's not going to help at all. But if I make it so that it only goes 2 meters, it'll only go that far. I can make it longer. I can make it longer. And if I click on any one bullet here, you'll see, actually, they're probably being despawned so quickly that it's hard to click on one without it being destroyed. But now you're economically, it's important to do this. If you're going to create something and you're going to create a lot of them, you have to figure out when should I destroy it? Actually, when you're doing something like creating bullets, there's actually an even smarter way of handling it, which is don't instantiate and destroy. Instead, you do what's called object pooling, which means you create a bunch of bullets and you put them over here. And when you want a bullet, you grab a bullet, you use it, and instead of destroying the bullet, you put it back in the bin off to the side. So technically, this isn't the best way of creating bullets. I'm just showing you. This would be a good way to spawn enemies. If you're like, oh, I keep spawning enemies until a certain point. But for bullets, you would use object pooling. But we won't get into that because that's a bit more advanced. So there's only 10 minutes left of class. And so what I'm going to do is I'm going to go through some of what we talked about, or go through some of the stuff we won't cover this next. So we covered this. We won't cover this part on triggers, but it's okay because we're going to do this in the animation class that's coming up. We're going to use triggers to trigger interactivity. So, for example, we could add a third-person controller to our game, and we've done this before. And we could create, set all this up, and we could create an object that has a box collider set to its trigger, and we could detect when the player enters the trigger, and we could do stuff based on that happening. And what we'll do in the animation class is when the player steps into an invisible trigger, we'll have a door open. And then when they walk through that trigger, the door will close behind them. So this is something that we'll do later. We were going to do this as a preview here, but the point is, when you can, when you know that, like, okay, if the player steps into this invisible box, if I've set it to is trigger, they won't hit it and stop. Instead, they'll step into it and the code will know, because the code, you can use on trigger enter to know when something has stepped into a trigger that's attached to the game object that has the script on it. And so we'll go through that. But you can imagine, you can do all kinds of stuff if you can detect when the player walks into a trigger. You can have an NPC start talking. You can have a door open. You could spawn a new wave of enemies. You could, the possibilities are endless. So that's a very common thing to do, is to use triggers to create interactivity. Triggers being invisible volumes that the player can walk into. So you could detect that the player falls out of the world and respawn them. We actually did that in the 2D microgame tutorial, 2D platformer microgame tutorial. You can know when the player touches a hazard and damage them if they touch fire, if they approach an NPC and start a conversation, or they touch a power-up to give them a superpower, or they cross the finish line to win the race. If you're interested, you could try to do movement, spawning, and despawning. And I'll give you some tips for the remainder of the class. One is, if you're having trouble understanding script or don't understand why something's broken, copy and paste your script into ChatGPT. ChatGPT is actually really good at, if you say, I'm using Unity 6 and there's a problem with this C# script, can you tell me what it is? And then copy paste the script into ChatGPT, it'll tell you what you've done wrong. It knows, it's actually quite good at doing that. Now, what you've been doing is you've been scripting by typing in text, which is one of the most common ways of scripting, or writing code in general. But there's other ways. There's something called visual scripting. This is something that you can do in Unity and you do in Unreal Engine. So for example, visual scripting just means that there's these nodes that you connect. And so it looks more like a graph. So instead of trying to type code, you actually will connect nodes in a graph. And Unity has built-in visual scripting. It does it. It's one of those things you have to add to it. This is
That's why it looks fancy.
yeah.
That's why our background must be.
You're used to this a little bit
Yeah,
more.
we use this. I
Yeah.
feel that's what the background is C# this is.
Yeah, and actually, Unreal does this with something they call blueprints. So you can set this up. It's actually a little tricky to set it up in Unity, but you can set up visual scripting in Unity. There's tools like Stencil that use a block-based system like Scratch, but Unreal. So this is what Unreal blueprints look like, and so this is how you script in the Unreal Engine, is in this kind of flow chart kind of way. Mm-hmm. But the problem is that it can get a little crazy. Like, so, if you don't do visual scripting well, you can create these complex, it's like, well, why don't we use visual scripting for everything? Well, for one, it's not as efficient as code. Like, if you're scripting something simple, like this is no big deal, but this is called UE4 Blueprints from Hell, and just goes to show you that something like this shouldn't be built in a visual script. This should be turned into code, and it should be simplified. This is a nightmare, both to try to debug, and it doesn't run well. So while it's an interesting tool, I think that you should try out both and understand the strengths and weakness of both. And like I said, there is both a component you can add through the package manager in Unity to give you access to this. And there's tutorial, like this tutorial, Introduction to Visual Scripting. So you can totally. Mm-hmm. So for example, here is, there's a whole course in Unity Learn about how to use visual scripting. And it'll teach you, although visual scripting has its limitations, and sometimes you have to figure out how to make connections to things that it doesn't give you by default. You have, when you script using code, you have access to a whole lot more commands than you get through visual scripting. And you can do a lot more. So you may find, like, visual scripting can be useful if a coder sets it up for you, or if you're only doing limited things, but you're not gonna have access to everything that the engine can do. Whereas once you get used to this, there's pretty much nothing you can't do. And they can get pretty complicated, but but the power of knowing how to write C# or C++ or Python is really valuable too. So I think you should definitely try and understand both of them, including visual scripting, because it's cool. And some people, it's easier to follow what's going on, especially things like loops and branches and stuff like that. And actually, the shader tools for creating interesting visuals use these kind of node graph structures. And so this is a common way of just creating logic in general. So yeah, I'll definitely recommend you check that out. But yeah, that's all for tonight. So I'm going to go ahead and shut down the stream. Thanks to those of us who joined us on the stream. And we'll see y'all next week.